2.2 is intramolecular force and potential energy. So our outcome is I can explain the relationship between potential energy and distance between atoms in covalent and ionic bonds. So first you're going to have to access the PhET simulation. You will use this to investigate the attractive and repulsive forces that govern the interactions, the bonds that can occur between two atoms. So review the controls that are available. You can scale the graph. You can view the interaction between the atoms. You can either drag the unpinned atom or the dot on the graph. This allows you to choose pairs of atoms to investigate, or you can do custom set. And then there's hide or show the forces that are occurring between the atoms. So with hide forces selected, we want to describe what we see as we move the atoms from points A, B, and C on the graph. So if I start at point A here, right, so that's somewhere around here, and I release this, there's this repulsion that pushes this atom away. If I let it go around point C, there's a net attraction that attracts them together. And if I put it at point B, right there in the middle, in the bottom of that well, we see that they neither attract nor repel. So they remain near each other and they're able to form a bond. So now we want to do the same thing, but this time we want to observe it with total forces selected. So I'm going to go ahead and select total force, and again, look at the different points. So at point A, we see that there is a net repulsive force. And we see that very quickly, as these guys get too close together, that repulsive force gets very large. Here, if we're at point C, there is a weak attractive force between these molecules, or between these atoms in this molecule. If we put this right in the bottom of the well, we see that those total forces kind of go opposite of each other, right? So they increase as they get closer together. Eventually they get too close and then they start to repel. So let's go ahead and look at what that looks like with each individual force. So now we can see the attractive and repulsive forces. And we see that at point A, that the repulsive force is much stronger than the attractive force. So this is due to overlapping electron clouds, and those are much larger than the attractive forces between electrons in the nucleus, so the atoms will repel. At point C, we see that there is a net attractive force, and as they get closer together, the repulsive forces will get stronger. If we keep this at point B, we see that the size of those arrows, repulsive and attractive, are the same. So the forces here are in balance, and they keep those atoms a certain distance apart, which allows a bond to form. So our reflection question here is asking, how does this graph of potential energy versus the distance between the atoms help us to figure out bond length and bond strength? So on our graph, the bond strength is represented by the depth of this well. So the deeper this well is, the more stable that molecule can be in terms of its attractive and repulsive forces. So that really is a measure of the bond energy. Bond length can be measured from the distance that's between the atoms. So wherever the bottom of this well lies, that gives you the distance that has to be between those atoms for those forces to be in balance. So that's going to give us the bond length.